Hi Year 11. Now a lot of these will be fairly straightforward from the mark scheme, but some of them you may benefit from a little bit more of an explanation. So, question 1 says, in a laboratory a radiation detector displays a count rate of 16 counts per minute due to background radiation. Now don't worry about the per minute per second, that will be variable depending on the exam. You can write per minute per second, it doesn't matter. So, state what is meant by background radiation. Well, what that is in the environment there will always be radiation detectable, even without a radioactive sample. So literally all you're going to write is radiation that is always present in the environment even without a radioactive sample. That's straightforward, that one. Okay, so next, a sample of a radioactive isotope is placed near to the radiation detector and a count rate of 112 counts per minute is recorded. After 18 hours, the count rate recorded is 28 counts per minute. Determine the half-life of this isotope. Now, as it's part II, this 16 counts per minute background is still relevant. So actually, this 112, the actual radioactive isotope is not emitting 112 counts per second, it's emitting 112 minus the 16, so 96 counts per minute. Okay, now after 18 hours, the count rate is now 28 counts per minute. Well, again, it's not, it's 28 minus 16, and that's 12 counts per minute. So the first thing you have to do is always make sure that you've accounted for background radiation. So to then calculate the half-life, we know that T0, so the original value, we had 96 counts per minute, and then after one half-life that will be halved, and so I will have 48. After the second half-life, that 48 will be halved, giving me 24, and then by the third half-life, that 24, will have reduced to 12, and that was the value that we are looking for. So therefore I know that after 18 hours 3 half-lives must have occurred, so 18 over 3 gives me 6 hours, so my half-life is 6 hours. Now lastly, it asks you to state 2 precautions to be taken when radioactive isotopes are used. Now I'm going to list all of the options, but it specifically bolds the word 2, so if you give 3 or 4 you're actually going to end up losing marks, so don't do that, only give 2. So obviously we can use tongs when we handle them so that we're not physically touching them. We can wear protective items such as lead gloves or vests, or potentially use a lead shield. So any kind of reference to using a screen or something physically as a physical barrier would count as one of those. So you couldn't have lead gloves as number 1 and then use lead shield as number 2. That would count as the same mark. So if you didn't have those, you could have limited your exposure time, or fourthly, keep the sample in a lead-lined box when not in use, so that it's not out and emitting radiation when we don't want to be measuring it. So that's question 1. Let's go on to question 2. So let's look at the graphs. So in a research laboratory, a radioactive sample is placed close to a radiation detector. The graph in figure 1.1 shows the decay of the sample. After 6 days, the count rate hardly decreases, and in fact increases a little at times. Explain these observations. Okay, so the first thing I'm going to say, sorry I keep making this wonky while I'm writing. So the first thing I'm going to say is that after 6 days, although the sample has fully decayed, background radiation is still being recorded. So that's 1 mark for identifying the fact that we know that there's background radiation. So that's 1. And then the second point is that background radiation, although we get given a count rate reading, so like in question 1 we were told 16 counts per minute, it's an average. So background radiation actually fluctuates a little. And so this explains how it could increase a little. Okay. So the next thing you're asked to do is to use the graph to determine the half-life of the sample. Let me move that up for you so you can see. Can we get both bits? Now, the mark scheme allows a range. I'm only going to calculate 1, otherwise I'll be here forever. But they give you a tolerance. So, the first thing you have to do is obviously work out what the background reading is. So what I'm going to do is I'm going to look for where it flattens off on the graph, and I'm going to take the range for you. So they allow between 13 and 15. So if I look here, I've got 12, there's 13, there's 14, there's 15. And if I track across for you, you'll see that the 13 accounts for the lowest background reading point, this one here, and the 15 accounts for the highest. So they will allow on the mark scheme for you to have decided that the background reading was either 13 or 14 or 15 based off of that. So I'm going to take 15, okay, for my background. It's okay if you chose a different one. So now I look at the original value of the count rate, and you can see that at t equals 0 I had 52 counts per minute, but I actually didn't. So what I actually had was 52 minus the 15 background, so I had 37 actual counts per minute. Okay, so now I'm asking to find the half-life, so I know that after 1 half-life, the 37 will have halved. Okay, so I'm looking for a count rate of 18.5, but obviously I'm not going to look for 18.5 on the graph because there will also have been the 15 counts per minute of background radiation. So on the graph I'm looking for 18.5 plus 15 gives me 33.5 counts per minute. So that's where I'm going to look. So there's 32, there's 33, 33.5 is around here somewhere. So I'm just going to track across to where I meet the graph. I'm going to track down here, and hopefully what you can see is that's 1.2, 1.4, 1.5. I think it's in days, yeah, days, 1.5 days. So therefore I know this occurs at 1.5 days. You obviously were allowed a bit of a range because of the fact that you might have chosen 13 for your background or 14 for your background. So that's absolutely fine, but that's the process of how you calculate that one. Sorry, I've made that wonky again. Okay, so lastly in this question, another radioactive sample is a strong emitter of alpha particles and gamma rays. A junior researcher suggests that a sufficient safety precaution would be to use long forceps. Okay, so forceps is just tongs, so they're suggesting just using tongs to hold your sample. why would that be insufficient? So you have to recognise that in the question they refer to both alpha and gamma. So because it's out of 2, I'm going to refer to both of those. So I would say, so alpha is stopped by air. So forceps would be sufficient to protect from alpha. That's 1. But then 2, gamma is highly penetrating, and so forceps would not be good enough. So therefore we would need more shielding. Okay, so always check how many marks are available, and then if they reference 2 different types of things in the question, don't just jump to talking about the gamma rays. Okay, they're asking for both. So the last question you were asked to do, you've got another count rate graph. So originally for 10 minutes the detector is only detecting background radiation, because it says 10 minutes later at time t equals 10 minutes a small sample is removed and placed near to the detector. So really straightforward. The first thing we are going to do is look at this value here, and that's obviously at 12 counts per minute, so the background radiation is just 12 counts per minute. Now you need to put the counts per minute and not just the number 12, okay, because count rate can be measured per second, per minute, per hour, so you need to show that you've acknowledged that. Okay, so use the figure to determine the count rate due to the radioactive sample at t equals 10 minutes. Okay, so we look at the spike, and at 10 minutes, hopefully what you can see is that that's at 84, if I track across here. Ooh, sorry, it's not a very straight line. So at t is 10, I do have 84 counts, but I'm going to minus the 12 background radiation, and I get 72. So I get 72 counts per minute. And at t equals 19, you're going to have to be very careful here. This point at t is 19, if I track up, at first glance I actually got this a little bit wrong because I wasn't being careful enough. It's actually halfway here, okay, and so it's actually not at 20, it's at 21, so be very careful when you're measuring. So 21, but obviously minus the 12 for the count rate gives me 9, so I've got 9 counts per minute. So you can hopefully see how careful you have to be. Okay, oh, sorry, useless. I will get better at recording these videos, but hopefully that has helped you.